Good morning. Today we're going to be talking about laws of sines. So what we've been doing, all the right triangle problems are, as definition, right triangle problems. But not every triangle you run into is a right triangle. So how in the world can we find the angle measures and the side lengths if we don't have a right triangle? Because of course you can't use Pythagorean's theorem. So what we have, laws of sines and laws of cosines. And these are going to break down into two separate lessons. We're going to start with laws of sines, and then we're going to talk about laws of cosines. And then we're going to put everything together, and we're going to start solving some real world real world triangle problems. There we go. So we're going to start piece by piece, and we're going to begin with laws of sines. And of course, the information here is in the box in the center, so definitely you need to memorize this. So the relationship between sides and angles. The sine of angle A over the length of A is equal to the sine of angle B over the length of B is equal to the sine of angle C over the length of C. And again, please don't try this with a right triangle. It's not going to work. It has to be a triangle that's not a right triangle. So let's just jump down into it. We've got triangle ABC. The first thing you need to know is to label. So opposite angle A is side A. Remember, across the angle is your side length. Opposite angle B is side B, and opposite angle C is side C. The other thing you need to remember, the larger the angle, the larger your side length is going to be. The smaller the angle, the smaller the side length is going to be. So it appears to me as I'm looking at this triangle that angle B is the largest angle, which means length B will be the longest side. So just kind of keep those basics in mind as you're working through this. All right, so everything here is unknown to me. I've got ABC triangle, and I know that this is a 90-degree angle right here, which means I'm going to be needing to find angle A, angle B, and angle C. So bear with me just one second. So I know that, and let's just talk about what the relationships are here. I know that the sine of angle A to the side of angle A is equal to the sine of B to the length of B is equal to the sine of C to the length of C. And there's a piece of information left out of here that should be in here, and that is B is 130 degrees. Okay, so if we know that, then we're going to assume that this has been cut in half here for my 90-degree angle. Come up. So if I have bear with me just one second. I think I've taken you down the wrong path here from the beginning. I think I'd rather start off with a different triangle and make this a little easier. I'm sorry, I got a little out of order. So hang on just one second. Well, just get a blank piece of paper if you would, because I started off a little over anxious here. All right, let me give you another triangle. Okay, we have triangle A, B, and C. We're still using laws of sines, and some of the information I'm going to be providing for you is that angle B is 30 degrees, Angle C is 45 degrees, and side length B is 9. I think this is going to make the whole concept a little bit easier if we start off here. Okay, so remember, opposite angle B is side B, opposite angle A is side A, and opposite angle C is side C. So we have been told that B is 30 degrees, C is 45 degrees. So angle A, well, that's not going to be too hard to figure out because I have 180 minus 75. So angle A is 105 degrees. Which means what? Side length A is going to be our longest side length, and side length B is going to be our smallest side length. Okay? So I know that the sine of A over side length A, sine of B over side length B, sine of C over side length C. So think about that for just a second. And where do we want to start this pattern? Well, I've got angle B and side B. I was given angle C, so let's go find side length C to begin with. They don't all three have to be in the equation at the same time. You can just have two pieces. So I'm going to start with the sine of B over B, the sine of C over C. So the sine of 30 degrees over 9 is the sine of 45 degrees over I don't know. Okay. I know these are major angles, but you don't have to do these by hand. You can use a calculator for this. And we want to make sure we're in degrees. I'm sorry you can't see that, which we are. Let me get this over here. Okay, so here we go. Sine 30 over 9, sine 45 over C. I'm solving for C, so I'm going to multiply my denominator. So I have C sine 30 is 9 sine 45. Or C is equal to 9 sine 45 over sine 30. Okay, so here we go. Am I on the screen? I am not. So 9 sine 45. I would evaluate that before you divide it, because sometimes the calculator reads things differently than you'd like it to be read. Divided by sine 30, which of course is 1/2, so it's going to be times 2. So side length C is 12.727. Okay, so out of our triangle we know, let me come up here and make this a little cleaner for you. Side B is 30, or excuse me, angle. Angle C is 45, angle A is 105. Length B is 9, that was given. We just found length C, 12.727, and now we're looking for length A. Well, we know length A has got to be the longest length we have, and we were given all the B information, so let's just go back there. Sine B over length B, sine A over length A. And at this point, if you're asking, well, why don't you just use Pythagorean's theorem? Remember, these are not right triangles. We can't use Pythagorean's theorem. So here we are. So I've got sine 30 over 9. And again, that was the given, so I'm just going to stick with using that. Is sine 105 over I don't know. We're going to cross multiply. the length of A times the sine of 30 degrees is 9 times the sine of 105 degrees. Or A is 9 times the sine of 105 degrees divided by the sine of 30 degrees. All right, go into our calculator. 9 sine 105 divided by sine 30. And the length of A should be 17.386. And again, you have to ask yourself, does that make sense? And if we come back up to where we have everything stored, our largest angle has our largest side measure. Our smallest angle has our smallest side measure. So that is exactly what we're looking for, and that's where we want to be. Okay, let's look at another problem. Again, I'll provide you the data here. We've got a triangle. Triangle ABC. Side A is opposite angle A, side B is opposite B, and side C is opposite C. All right, so what we know now, angle B is 35 degrees. Angle C is 50 degrees. Hang on one second, I think no, we're good. Okay, and side B is 9. Okay, so angle A, well, of course, we've got 180 minus 35 minus 50. So I've got angle A is 95 degrees. This one's going to be very similar to the one we just worked because we've still got the longest side is going to be corresponding with angle A. The shortest side is angle B. But we know what we know, so here we go. Sine B over B is sine C over length C. So the sine of 35 degrees over 9 is going to be the sine of 50 degrees over length C. We're going to cross multiply. C sine 35 is 9 sine 50. Length C is 9 sine 50 over sine 35. I would evaluate the numerator first and then divide it by your denominator. And you have a side length C that is 12.020. Now, of course, I have to find side length A. So they gave me everything on B. And again, I would use the angle that you have all the information on, because if you're making any kind of math mistake, you're going to throw off all your calculations. So I'm going to use sine B over sine A. So sine 35 over 9, sine 95 over a. And we're expecting this length to be larger than 12. Cross multiply, a sine 35 is 9 sine 95. That's a 9, not a 7. So a, the length of side A is 9 times the sine of 95 degrees over the sine of 35 degrees. Okay. So I've got 9 sine 95 divided by sine 35. The length of A is 15.631, keeping in line with what we were expecting. So there you go. All right, let's do one more. Again, just draw an ABC triangle. I know it seems simplistic to label the sides A, B, C, but it is so easy to make a mistake when you're working these. So just be sure you get it straight in your head what's where. All right. We're going to be told that angle A, angle B, angle C, side A, side B, side C. We know that side A has a length of 10. We know that side C has a length of 7. And that angle C is 30 degrees. So now we have to find angle A based off that information. First of all, I know angle A is going to be greater than 30 degrees because the side length is 10. So here we go. Sine C over C is sine A over A. Just set it up. So sine 30 over 7 is sine A over 10. All givens. There's no magic here. Let's cross. Actually, you're not going to want to cross multiply because here's what you're solving for. So let's get the 10 to the other side. So 10 sine 30 divided by 7 is sine A. So now you're saying what angle has this sine. Now you get into your inverse. So first of all, I would evaluate 10 sine 30 divided by 7 before I went any further with this. So 10 sine 30 divided by 7. So some angle has a sine value of 0.714. Can that be? Well, think about your sine values, right? Negative 1 to 1, 0.714 falls perfectly in that area. We're good to go. Second sine, and we get an angle measure of 46 degrees. Okay? So a little trig inverse there. So if this is 46 degrees, then I've got to figure out angle B or else I can't find side length B. So again, we have 180 minus 46 minus 30. Angle B is 104 degrees, which tells you what? The length of side B is going to be the longest length we have. So let's go find that. Here we go. Sine 30 over 7 is sine 104 over I don't know. I'm solving for B. I need it out of the denominator. So B times the sine of 30 degrees is 7 times the sine of 104 degrees. So again, I'm isolating B. That's what I'm solving for. So B is going to be the 7 times the sine of 104 degrees divided by the sine of 30 degrees. Okay? And again, every time I would evaluate the numerator, then divide it by your denominator. We know it's going to be times 2 because it's divided by a half. So the length of side B is 13.584 units. Okay, so now, again, if we go back over to the, yeah, I don't even know if we need to. Let's just move on. We'll revisit that later. I've got a few more problems, and I'm not sure that I sent you this sheet. So on a separate sheet of paper, here we go. Let's look at a couple problems. We've got a triangle. Angle A is 64 degrees. Angle B is 98 degrees. And length A is 29. Find the missing parts of the triangle. Okay, so first of all, I can find angle C, 18 degrees. Which means what? Well, side length B is going to be the longest length we have, and side length C is going to be the shortest length we have. But let's see if we can find side B. So I have the sine of 64 degrees over 29. Sine A over A is sine B over B. So B sine 64, 29 sine 98. A little bit of algebra there. And we have 29 sine 98 divided by sine 64. And the length of B is 31.951. See if we agree. All right. So what do we know about C? Well, same as before. Sine 64 over 29. Sine A over A is sine C over C. So C is equal to 29 sine 18 over sine 64. So I did 2 of the algebraic steps and 1 there, multiplied by both denominators and divided by sine 64. Okay, so length C, 29 sine 18 divided by sine 64. Length C is 9.970, and let's see if that makes sense. Longest or largest angle, longest length, smallest angle, smallest length. That all makes sense, and we're good to go. Okay, let me throw this problem up here for you, and you may want to think through this one. We've got triangle ABC, as always. Okay, so I've got side A, side B, and side C. And we're going to be told that angle C is 128 degrees and side C is 35. We're not going to get any other angle measures, but we're going to be told that side B is 35. So now you're going to have to use inverse to find what angle has this sine measure. So if we use sine C over C is sine B over B. Some of you probably already see the problem, but in case you don't, let's just continue. So I've got sine 128 over 35 is sine B over 35. So if you haven't seen the problem yet, you might now. Remember, if I have two fractions and they have the same denominators, what does that mean? Their numerators have to be equal, right? If something over 35 is equal to something over 35, the somethings have to be the same. Which means what? Angle B would have to be 128 degrees, and clearly that is not possible. So we'll have no solution. But let's just say you didn't see it at that point. Well, if you multiply both sides by 35, right, now you have 35 sine 128 over 35 is sine B. Those would have canceled out, and now clearly sine 128 has to be sine B. And again, you can't have that. So be careful when you're working these that you don't take a wrong turn there. All right, let's do a couple practice problems. You do have the A62. I'm trying to see if there's anything else that's a little tricky, and I don't think there is. Hold on a minute. No, I think we're good. Let's look at our practice problems. Which will look like this. A62 worksheet laws of sines. All right. Solve each triangle for missing parts. Draw and label the triangle. I can't impress upon you enough how important that is. It's just easy to get lost. And when we start mixing laws of cosines in with this, it's really easy to get lost. And of course, always 3 decimal places. So I have triangle ABC. Side A, side B, side C. I know that angle A is 45 degrees, angle B is 60 degrees, and side A is 14. So I've got a complete set with side and angle A. So sine 45 over 14, sine 60 over length B. B sine 45, 14, sine 60, B, 14, sine 60, over sine 45. Okay. (14 sine 60) divided by square root of 2 over 2, and you get a length of 17.146. Now we need to find all of C. So what do we know? Well, I've got 180 degrees in my triangle, and I'm taking away 105. So angle C is going to be 75 degrees. And again, no magic there. We're just subtracting from 180. Well, I guess that's kind of magical. All right. So sine 45 over 14. Sine 75 over C. And C is going to be 14 sine 75 over sine 45. And we would expect that C is going to be the longest leg of the triangle because it has the largest angle measure. So if you don't get a value that's larger, you've probably done something wrong, but at least you can check. And we get a value of C of 19.124. Okay. Okay, if we have time, we'll come back and do the evens, but let's just do the odds right now. So here we go. We're looking for a side length in problem 3 also. We have angle A, or excuse me, angle B and C. So I've got 30 degrees, there's side B, 45 degrees, there's side C, and there's side A. And B has a length of 9. So again, I don't know anything about angle A at all, but I've got all of B. So sine 30 over 9, sine 45 over C. So C is going to be 9 sine 45 over sine 30. So we have a length of 12.27, or excuse me, 12.727. And we know that angle A is 105 degrees. 180 minus minus. And so sine 30 over 9, sine 105 over A. My A's and my 9's look a lot alike, so be careful. Okay, so length A is 9 sine 105 divided by sine 30. And we have a length of 17.386. Again, that makes sense. We're good to go. All right. Oops, excuse me. Let's keep going. And we'll come back and do the evens if we have time. And if not, I'll give you the answers to them. All right, problem 5. Now, I like this one better because it's not as, at least we get some inverse in here. We've got all of side A and angle A, and we've got the length of side B. So now we're going to be looking for angle B. So I've got A, B, C. A, B, C. And I know this is 76 degrees, and this is 12, and that's 4. That's all I know. So I can't at this point find angle C or B. But if I use laws of sines, then I can find angle B. So here we go. The sine of 76 degrees over 12, angle A over length A, is the sine of angle B, which I don't know, but I do know the length of B. So 4 sine 76 over 12 will give me the sine of angle B. And again, you're asking what angle has this sine. So be careful with that. So I would evaluate this number first. And we end up with 0.323. So what angle has the sine 0.323? And we've got angle B is 19 degrees. Great. Now we can find angle C. So I've got 180 minus 76 that was given minus the 19 we just found. So now again, we're going to find length C, so sine 76 over 12 is sine 85 over I don't know. So the length of C cross multiply, isolate C. Okay. All right. Let's look at 7. Well, right away we're being told that length C and length B are the same, which means what? Angle C and angle B would have to be the same. Please remember these are not drawn to scale. So if this is 88 degrees with a side length of 7 and B has a side length of 7, can angle B be 88 degrees? Well, I'm pretty sure it can, because what? We have 180 minus 88 minus 88, which gives you room to maneuver. I'm sorry. That means angle A is only going to be 4 degrees. Well, that's fine. It can be. So half our work is done here for us. B is 88 degrees. How nice is that? Meaning angle A then is going to be 4 degrees. Now, clearly it's not drawn to scale, but here we go. So now I've got sine 88 over 7 is sine 4 over, I don't know. So A is going to be 7 times the sine of 4 degrees divided by the sine of 88 degrees, which is almost 1, right? Because the sine of 90 is 1. And we're at 88 degrees. So 7 sine 4. We're going to be really, really close here, divided by sine 88. So close you can hardly tell the difference. And the length of A is 0.488. Okay? All right, let's go back old school a little bit and remind ourselves of some other things. Problem 11. Convert from degrees to radians. These are not major angles. So remember, you put it over 1 times pi over 180. So what, 72 over 90? .8, so I have 4 pi 5. And problem 12, convert from radians to degrees. So we're going to multiply this by 180 over pi. Of course, the pi's cancel out. And you have 5 times 20, so we have 100 degrees. All right, problem 13. Find 2 angles, one in a clockwise and one in a counterclockwise direction. Remember, if we are in our unit circle, we move normally counterclockwise. So if I'm at 143 degrees, give or take, here, and I want to go around again, I'm going to add 360. So I've got 503 degrees if I'm moving in a counterclockwise direction, which is the way the circle goes anyway. If I'm moving in a clockwise direction, then I'm going back to 0, right? And then I'm going to start counting again. So I've got, I'm kind of out of room here, but 360 minus 143. And I've got negative 217 degrees, because I'm going to go from 143 back to 0 and then start counting again in a negative direction. So same thing here. Remember, I need to subtract 2 pi from this. So I have negative 5 pi 4 minus 2 pi. 8 divided by 4 is 2. So I end up with negative 13 pi 4. And if I'm going counterclockwise, I'm starting from a negative position. So negative 5 pi 4 plus 2 pi. And I end up at 3 pi 4. So just remember, the standard movement of the unit circle is counterclockwise. All right, draw each angle in standard position, find the reference angle and label it. And basically we're just saying, okay, if you're at 144 degrees, well, clearly here's 90, here's 180, I'm right in here. How far away am I from 90 degrees? Well, you're 54 degrees away here. And how far away are you from I did not draw that angle in the right position, but that's all right. How far away are we from 180? And of course, we are 36 degrees. And these two numbers should add up to 90 because there's 90 degrees between that. So again, if I'm at 7 pi 4, 1, 2, 3, 4, 5, 6, 7 pi 4, well, I'm pi over 4 away from 3 pi 2, and I'm pi over 4 away from 2 pi. All right, so that's really all we're asking here. And 15, determine the quadrants where the following is true or are true. I'm sorry, cosine and cosecant have opposite signs. So I'm going to start with cosine. And cosine is positive, negative, negative, positive. That's cosine. Now remember, cosecant is 1 over sine. So that's going to depend on my y value. And my y value is positive, positive, negative, negative. So where do we have opposite signs? Clearly in quadrants 2 and quadrants 4. All right. Hang on, I think that's it. Yeah. Okay. And then cosecant is negative and tangent is positive. Well, again, cosecant being 1 over sine, so that depends on my y value. And my y value is positive, positive, negative, negative. Now, tangent being positive, I've got sine over cosine. And in quadrant 1, sine is positive and cosine is positive, so tangent is positive. In quadrant 2, sine is positive, but cosine is negative, so that gives me negative. In quadrant 3, they're both negative, cosine and sine, which gives me positive, and in quadrant 4, one's positive, one's negative. So cosecant is negative. All right, well that now restricts me to quadrant 3 and quadrant 4. And tangent is positive, only quadrant 3. All right, that is it for today. You have all the answers. I've sent them with the blank papers on this. And the next lesson we have will be laws of cosines. Then we'll put it all together, and then we'll do some right triangle problems. And that should get you pretty close to being ready for calculus. That's all we have. Have a great day. Thanks, you guys.